The job description of a site reliability engineer, SRE, centers on ensuring the reliability, availability, and performance of software systems through a blend of software engineering and systems administration practices. Site reliability engineers bridge the gap between development and operations by applying engineering principles to infrastructure and operations problems. They are instrumental in creating scalable and dependable systems that meet service-level objectives and minimize downtime, making them crucial in today's cloud-native, DevOps-driven environments. SREs often work in tech-forward industries such as cloud computing, e-commerce, fintech, media, and enterprise SaaS platforms, but their role is increasingly relevant across all sectors reliant on digital systems. At its core, site reliability engineering involves writing code to automate manual tasks, managing incidents and outages, and designing robust systems that can self-heal and recover gracefully. Unlike traditional operations teams that rely heavily on manual intervention, SREs emphasize automation, observability, and resilience. The position demands a hybrid skill set. SREs must think like software engineers while having the operational mindset of system administrators. This fusion enables them to troubleshoot complex systems, implement proactive monitoring, and write scripts and tools to eliminate repetitive tasks. Their work not only improves service uptime but also ensures that user experiences are consistent and dependable even during peak loads or unforeseen disruptions. Key responsibilities of a site reliability engineer. The primary responsibility of a site reliability engineer is maintaining the health and stability of critical services. SREs build and maintain tools for deployment, monitoring, incident response, and capacity planning. They work closely with development teams to ensure that new code releases do not compromise system performance or reliability. This collaboration involves reviewing code, defining service-level indicators, SLIs, objectives, SLOs, and agreements, SLAs, and ensuring that all production deployments align with reliability goals. Incident management is a significant aspect of the SRE's job. When something breaks, SREs are among the first responders. They analyze logs, metrics, and system behaviors to pinpoint root causes and implement fixes. But their job doesn't stop at resolution. After every incident, SREs conduct postmortems to identify underlying issues and propose long-term improvements. This blameless, data-driven approach ensures continuous learning and system enhancement. Another major function is automation. SREs aim to reduce toil, repetitive manual work, by scripting and developing tools that streamline operations. Whether it's writing a script to automate server provisioning or building a dashboard for real-time performance monitoring, SREs use code to make infrastructure management more efficient and less error-prone. Over time, their automation efforts translate into faster deployments, reduced human intervention, and greater system reliability. Monitoring and observability are also crucial in the SRE toolkit. Site reliability engineers design and implement systems to track the health of applications, infrastructure, and third-party services. This includes setting up alerts, creating dashboards, and integrating telemetry tools like Prometheus, Grafana, Datadog, or New Relic. Real-time visibility into system metrics enables SREs to detect anomalies early and act before they escalate into user-facing issues. Capacity planning and scalability are often overlooked but essential responsibilities. SREs forecast infrastructure needs based on traffic trends, seasonal spikes, and product growth. They evaluate load balancing strategies, optimize resource allocation, and recommend architectural changes that enable applications to scale efficiently. When done correctly, this ensures that systems perform optimally even under stress. In cloud-native environments, SREs manage containerized applications, often using Kubernetes, Docker, and CI/CD pipelines. They also interact with infrastructure as code tools like Terraform or Ansible to manage cloud resources declaratively. Security, compliance, and cost optimization are part of their broader mandate, particularly when operating at scale in platforms like AWS, Azure, or Google Cloud. Midway through understanding the scope of this role, it becomes evident that the job description of a site reliability engineer encompasses far more than just firefighting. It is a forward-thinking, preventative discipline aimed at creating systems that are not only reliable but also measurable, self-healing, and aligned with user expectations. Critical skills and personal attributes. Success as a site reliability engineer requires deep technical expertise, analytical thinking, and a collaborative mindset. Programming skills are a must. SREs frequently work in languages like Python, Go, Bash, or Ruby. They also need proficiency in systems-level tools and cloud platforms, along with the ability to architect distributed systems that are resilient and scalable. A strong understanding of Linux, Unix systems is fundamental. From shell scripting to system calls, kernel tuning, and package management, an SRE must be comfortable navigating and managing servers in high-pressure scenarios. Networking knowledge is equally important. SREs should understand DNS, HTTP, TCP, IP, and routing to diagnose connectivity and performance issues effectively. Problem-solving skills are at the core of this role. Whether debugging a memory leak or responding to an outage, SREs must approach challenges methodically and creatively. They should be comfortable operating under pressure and making real-time decisions that minimize user impact. Communication and collaboration are vital, particularly because SREs interact with product managers, developers, QA engineers, and business stakeholders. Writing clear incident reports, conducting effective postmortems, and aligning teams on reliability goals require both technical fluency and interpersonal tact. Attention to detail is non-negotiable. Small misconfigurations can lead to massive outages. An SRE must think in terms of systems, dependencies, and edge cases, often anticipating failures before they occur. This mindset enables them to implement fault-tolerant designs that protect user experience. A growth-oriented attitude is also essential. The SRE field is rapidly evolving, with new tools, techniques, and philosophies emerging regularly. A commitment to lifelong learning, whether through certifications, online courses, or community participation, helps SREs stay at the forefront of industry best practices. Work environment and career prospects. SREs often work in dynamic environments that reward initiative and accountability. While standard office hours are common, on-call rotations and after-hours incident responses are integral to the role. Remote and hybrid opportunities are increasingly available, especially within global organizations that require 24/7 coverage. The career outlook for site reliability engineers is highly positive. As companies expand their digital services and shift to microservices and cloud-based architectures, the need for reliability-focused engineers grows. SREs can advance into roles such as reliability architect, engineering manager, or principal SRE, depending on their interests and expertise. Salaries for SREs are competitive, reflecting the technical complexity and business impact of the role. Compensation often includes base pay, bonuses, stock options, and performance incentives. Benefits such as professional development budgets, wellness programs, and flexible work arrangements are also common. Training and certification can enhance career progression. Credentials such as Google's Professional Cloud DevOps Engineer, AWS Certified DevOps Engineer, or Certified Kubernetes Administrator, CKA, are highly regarded. Participating in open-source communities, speaking at conferences, or contributing to DevOps forums can also raise one's professional profile. As we approach the conclusion, it's important to revisit that the job description of a site reliability engineer highlights a career that is both technically demanding and strategically vital. These engineers are guardians of uptime, champions of automation, and enablers of innovation within their organizations. Education and entry pathways. Most SRE roles require a bachelor's degree in computer science, information systems, or a related field. However, some employers prioritize practical experience and demonstrated skills over formal education, especially in fast-paced startups or open-source-oriented environments. Entry into the field often begins with roles such as systems administrator, DevOps engineer, or software developer. These positions provide foundational experience in coding, systems management, and incident handling. Aspiring SREs benefit from building a strong portfolio of infrastructure projects, mastering automation tools, and participating in internships or apprenticeships that offer real-world exposure. Open-source contributions, GitHub portfolios, and participation in hackathons or reliability challenges can distinguish candidates. Many successful SREs are self-taught engineers who have cultivated deep expertise through hands-on experimentation and continuous self-improvement. Conclusion. The job description of a site reliability engineer reflects a unique convergence of development, operations, and strategic thinking. These professionals are not merely support engineers, they are innovators, system architects, and reliability experts who shape how modern systems function and evolve. Their work safeguards business continuity, improves user trust, and drives operational excellence. For individuals who thrive in complex environments, enjoy problem-solving at scale, and are passionate about automation and resilience, site reliability engineering offers a fulfilling and impactful career path. With growing demand and a broad spectrum of opportunities, it remains one of the most promising roles in today's technology landscape.